All right, let's get started. All right, welcome to the Allison Loves Math podcast. I am super excited to introduce today's guest, Jonily Zupancic. She is the author of this new book, Making Mathineers. She's a coach, speaker, and a Mathineer, bringing math to life in classrooms for students and teachers. She's an expert in math instruction, assessment, and intervention at the preschool through high school levels. She lives in Ohio, where she began her teaching career 22 years ago. She currently supports teachers, schools, and school districts in enhancing instructional practices to maximize student learning. And you can find more about her at mindsonmath.com. So welcome, Jonily. I'm so excited to have you here today. And
thank you, Allison.
Congratulations on your new book. This is so exciting.
Thank you, thank you, thank you. And thanks so much for having me here today.
So, you talk in your first section of your book, which I was just reading, and I find it so interesting because I love stories. Everybody loves stories, right? It's just a part of being human is that we love stories. And you talk about using that when we're teaching math or using that to help students with math. Before we get into that, why don't we start with your story? Will you tell us about your story and how this book came to be, how your love of math came to be?
Absolutely. Absolutely. Little secret on my story, I was not going to be a math teacher. That was never in the cards. I started my college career in actuarial science.
Oh my goodness.
That's not even in the book. So I
will tell you, I actually did a summer internship as an actuary in college.
No way.
I thought about that also when I was majoring in math, and took one summer to know there was no way I could ever do it for more than a couple of months.
But you know what, Allison, that is so unbelievable, because I'll tell you how I got out of it. I was a sophomore in college, failed my first math class ever. So that was devastating. Yeah. And, oftentimes in schools, we don't extract the student stories often enough, especially in mathematics. Yeah. And so I didn't really know myself as a math person as well as I thought I did, because that first failure in mathematics was very devastating for me. So I could have retaken the class. I decided to just major in mathematics. So my bachelor's degree is in mathematics. Didn't know what I was going to do. Thought I maybe wanted to work for an insurance company, but it got into very close to graduating my senior year that I didn't have any plans and decided to go into math education. So that's how I ended up landing in math education. Went through, got certified, began teaching. And here was the second devastation. About 2 weeks into my first year of teaching, I realized I knew nothing about mathematics. I mean, I know that sounds crazy. Here I am with a math degree, and I really had this insecurity about mathematics. Why? Because I was teaching these great lessons. Of course, we make up these lessons as teachers. They're fantastic. We deliver them to kids. Everything's great. Then you assess the students and they don't get it. And I didn't know how to help them. So it was 22 years ago when I started teaching. And for all of that time, I have been on this journey to find out about all students' stories, what they know about mathematics, what they don't know about mathematics, and deliver instructional strategies that are going to target exactly every student's stories need.
That's fantastic. That's fantastic. I love, it's such a novel approach to math. So let's just dive in. How can teachers use stories to help students understand math?
So the number one way we can use stories is to gather the student perspective. The way that I do this is with some of my favorite questions and prompts. What do you see? What do you notice? And my favorite 3 words, not I love you, but tell me about. So whenever I give students what I call a stimulus, or something that's going to stimulate their thinking, a stimulus can be anything from a picture, an equation, a number, a set of numbers, a situation, anything we give in math. But here's the important part. Remove the question that's going to prompt solving. So we want kids to swim in making sense first, not that we don't ever solve, but if I'm going to gather their perspective and extract their story, I want them to be able to make sense. And I want to prompt them with a tell me about so I get their exact thinking. Once I know how they're thinking about the number, equation, story, or situation that I'm providing, then I can teach to their level.
And I love that moving around and not speaking the right words at the same time. I love in your book too, you actually start by introducing a lot of the students that you worked with, and you have these nice interviews at the beginning, just sort of, I think, really setting up, who they are as students. And I love you sort of break them down into different quadrants, in terms of who they are as math students, and those sort of little discussions and understanding the students like that can be so helpful.
It is, and we oftentimes think of kids as kids who get the math or have successes and kids that struggle. We think of these two camps of mathematics. And I wanted to illustrate the stories of these students to show that it's not binary. It's not one or the other. They're not a 1 or a 0. There are so many variations of their story. And it was really important to set that foundation and to use these students that have inspired me my entire career, inspired me to do better as a math teacher, and share their stories to show the perspective that students have and how I deliver based on that perspective.
Right. And it actually reminded me a lot of tutoring. So before I was a math professor, I tutored for years. Honestly, it was something that I started in high school. I did it throughout college. And the thing that I always loved about tutoring was you got to know the student's story, right? That's the one like huge benefit about it. And then you can speak to them about math, like exactly how they need to hear it or how they need to learn it, and you can address exactly what they're struggling with. And so I do love this idea of bringing that into the classroom, and obviously, might not be able to have the exact same level of, understanding their story in depth, because you're
Allison,
not having an entire 1 hour conversation every week with each student, right? It's impossible. But you can pick up on so many little things, as you're, like you had said in the book, walking through the classroom and looking at how they're responding to things and how they're discussing with the kids in their group and stuff like that. There's so much that you can pick up about a student's story from that.
That is such a great point, because what I decided early on was to give the tutoring approach in a full classroom. It's interesting because I think some of the learning centers, and I don't know that I should say their name, but what some of the learning centers are. And that's what I would call my teaching, because I was like, look, we can get down to the one-on-one level with students if we just use these prompts and gather their perspective. Then I can target my instructional delivery so much better to maximize learning for students. And that was always in the back of my mind. How do I create an experience that it's just like myself and that one student having a conversation? Great point, great example for that.
No, I love how you described it, because I think that was exactly my goal during my first semester of teaching, was exactly, how do I take what I did as a tutor? Because I found that to be so, not just rewarding, but impactful, right? And how do you apply that to an entire class? But one of the things that I found very sort of confusing about it is that there were just so many students, and how do you track everything? And I know one of the things that you talk about in your book is this difference between math ability and number sense. And you even have have this discussion of, where each of these students that you talk about, places, in these different quadrants. Can you actually, let's just start by maybe talking about the difference between math ability and number sense, just to get everybody sort of on the same page about those two things.
Absolutely. This gets pretty deep. It gets pretty heavy. This is really the gist of all of the work. It's the compilation of everything that's come together. It's the huge discovery that I made, and now I support schools and teachers in making to better serve our students. So I talked about these two camps that we place students in. There are two camps that separate math society. I mean, let's face it, in our world, in our society, not just in education, that mathematics is a separator. It separates people into the can and the can't of the math world. And what we want to do is not have those separate camps, but we want to describe students based on their successes and struggles. So there are two camps I want us to think about. The first camp I'm going to call the procedural camp, which is exactly what it sounds like: procedures, algorithms, long division, math facts, just knowing things, fluency, understanding automaticity. I'm going to call that whole procedural aspect math ability. Math ability is the math that we learn in school. It's math that we're not necessarily going to discover on our own through some of these inquiry-based experiences that I like to give my students. So that procedural camp is the math ability camp, the math that we learn when we go to school. The other camp is this conceptual camp. Conceptual understanding of mathematics. I'm going to call this number sense. Now, I know this gets a little bit confusing because it's like, well, you know, if we have number sense, don't we have to have math facts and know the procedures? I'm going to define number sense a little differently for the conversations that we're going to have. Number sense is going to be the conceptual camp of mathematics. And what I mean by this is the innate, inborn, just the way that we naturally think about numbers. Number sense is the understanding of how large or small numbers are. A word that I use for that is magnitude. So having number sense, and we're all on a range of a continuum of number sense, from strong to weak number sense, that we come into this world with, and number sense can help us have more success in school math with our procedural math, our math ability. But number sense is understanding the quantity, value, and magnitude of numbers. Now, here's the big question though. What if we don't have the number sense that another student has? Because we all are placed on a different level of the continuum. But have no fear. Everything that we do at Minds on Math has been to improve the number sense so that kids can be more successful in their math ability. You can't have one without the other. These are not competing interests. They must collaborate and work together. So as I'm gaining the student perspective, I'm finding out where their strengths and successes are, where their struggles are, and which of these camps is stronger than the other. I'm going to play on that with my instructional delivery to increase both and have both of these camps work together to have absolute maximum long-term learning experiences for our students. And I know this can get heavy and deep, maybe a little bit difficult to understand, and we break it down a little bit more in the book, but that's sort of the foundation and the definition of those two phrases, number sense and math ability.
I really like how you differentiate between the two. I think it helps to look at the student learning in a just a slightly different way, which is very, very interesting. And so what are maybe some tips you have for helping students who are maybe on the lower end with math ability?
That is a really great question. So if students are on the low end of math ability, the first thing I look at is assessing their number sense. Now, we have what we call, and this is mentioned in the book, we have what we call target questions. I'll give a couple examples of those. Target questions are prompts and questions that gain student perspective and figure out exactly where they are. And this is telling me where they are as far as strength of number sense. I've got to improve their number sense if I want to increase the math ability. So this is a really, really great question. So if I want to improve their number sense, I first have to find out exactly where they are. So a couple of target questions we use, and these are going to sound a little bit strange, and I won't go into all the detail about how we have come up with these questions, but it's based on a lot of research and evidence-based practices that we've looked into to make sure that we're sifting down to the best questions and prompts that are going to target exactly where students are. So one of our target questions is, how many nickels make a dollar? Now, I'm in the States, I'm in the US, and so we have the dollar system for money. So this works for us. You have to think about what your equivalent is if you use a different monetary system. But how many nickels make a dollar? When I would ask 7th and 8th graders, how many nickels make a dollar? The students that just know have a higher number sense. The students that have to figure it out or aren't even sure how much value or worth a nickel has, those are the students that I know have a weaker number sense, and in turn, many times have struggles with math ability or school math. Now, here's another target question that connects to that one. How many nickels make a dollar? If kids don't just know that, this affects their understanding of percentages. Another target question I ask is, what is 20% of 80? One of my favorite instructional strategies is to use best wrong answer. So the best wrong answer for 20% of 80 is 4, because students want to divide 80 by 20. The same students that struggle with just knowing 20 nickels make a dollar are the same students that give the best wrong answer, dividing 80 by 20 when finding 20%. Now, 20 nickels make a dollar. There's a strong relationship between the number 20 and the number 5 that we oftentimes don't embed in our instruction. And students miss this point if they don't already have it from their home experiences. So we want to give students lots of experiences with understanding money, coins, and the relationship of money and percent. So those are 2 of our target questions that we try to really get the student perspective, figure out where they are as far as their strength or weakness in number sense. And then we use our instructional practices to target those items, which will then increase their math ability or their school math, finding percentages of numbers.
Right, right. No, I think that's really interesting. As I'm thinking about teaching math at the community college level, you can see how students who are struggling with number sense, and so often, I'll say, I have students in a college course who can't multiply, for example, and you think of that just in terms of math ability, but you're right, when we talk about any sort of real life math questions, and I've never done the nickel example per se, but there's so many similar ones that can come up, and you see that there's just there's so much underneath some of those initial struggles that you might see at the college level. Which is why, so I guess if you're teaching the elementary school and the junior high math, right, this stuff is really, really important, because it's very hard to solve those problems by the time that they get to college and they're just trying to meet a requirement in one semester, because all of those gaps in foundations and all of those troubles are really deep at that point.
And I think a lot of the struggle and trouble is when we focus for the short term. Many of our instructional practices in mathematics aren't delivered in such a way that are going to promote long-term learning and retention. For example, the way that we typically traditionally teach math, we teach one unit, one chapter at a time. Nothing wrong with that. We need a linear progression. We need that linear foundation. We need that textbook model example to go from one thing to another. But just knowing that that is not the approach to take when we want students to have long-term learning or retention. So what should we do? And I think here's another question that is going to answer the question, how do we improve math ability? How do we improve number sense? And that is giving students out of context prompts and stimulus throughout the year that are not based on the unit or chapter that we're currently teaching. By doing that, we can give students more interactions with some of the essential important mathematics, especially some of those concepts and skills that don't come until the end of the book or the end of the year or the end of the curriculum map or the end of the pacing guide. We can bring some of those items in as stimulus that I talked about before, where we remove the question that promotes solving. So for example, if I'm teaching 5th grade, volume is always at the end. It's always later in the year. And so kids don't get a really good, strong grasp of volume. So what I might do in September and in October is show students some kind of rectangular prism and ask my favorite questions, give my favorite words. What do you see? What do you notice? And tell me about this shape. We can start having conversations at the conceptual level, just exposing them to this content. It's not based on mastery. I'm not going to quiz them on it, but I'm just going to give them an experience based on exposure, extract their thinking and their perspective, and give them more interactions with volume before we get to that unit. We know that our most struggling students, especially our students that have learning disabilities, all they sometimes need is more interactions over time. And by giving some of these out of context stimulus throughout the year, that's going to give students more interactions over time, lead to long-term learning and retention. So when they get to you at the college level, they're going to have a really strong foundation, and they're not going to have to memorize and try to just pull all of these rules and formulas. They're going to have an innate inborn ability to give the information at a very complex, high, rigorous math level.
Yes, and that opportunity to just explore a little bit, right? That tell me about question is so powerful because, I think it actually goes back to one of the things that you said in the book. You said that students ask you, why do I need math? And you say, well, when are you ever going to use thinking, right? Because you're teaching thinking. You're not necessarily a math teacher. You're a thinking teacher. You're teaching them how to think. And those questions that you were just talking about are really what teach that and allow students to sort of explore in their thinking.
Absolutely. And I'll tell you, there's a lot of criticism that comes to this. We've been through this road in the past 20 years, this old math and new math. And again, these are not competing interests. We need all of it. And I think there's a lot of miscommunication and misunderstanding and misconception. And, we're not, I would never want students to just create or discover or explore the long division algorithm. No, that's the procedural camp.
Right.
I think that's where we get mixed up in schools and where parents get mixed up with this understanding. No, if I'm teaching a long division algorithm, which absolutely is essential for students, then I'm going to give explicit, direct instruction, and I'm going to show them, I'm going to model, I'm going to have them mimic. That's what I'm going to do for that camp. But in the other camp, the exact opposite is what I need to do. And I think this is where we get confused in the education community, especially, is we try to lump everything together, all of these new initiatives that are coming out. No, let's keep them separate. Let's separate out what the procedural things are that kids need to know and what the conceptual things are that kids need to know. But know that the instruction for each of those is different. I know that research says, especially in the special education community, research says that kids need explicit direct instruction. Absolutely. But that only applies when we're in the math ability, the procedural camp. That is exactly where kids need explicit direct instruction. When we are trying to improve number sense, when we're trying to improve the conceptual perspective of mathematics with our students, we have to do the exact opposite of explicit direct instruction. And that is where we have to engage kids in experiences that are exploratory. And I do that through this tell me about type of delivery of instruction, where we give the stimulus better than not, that it's out of context from what we're currently studying, and ask students to tell me about and give them many of these stimulus throughout each month and each unit of the school year to gain better, bigger interactions, more interactions over time, and also allow them to engage in experiences that are going to improve their conceptual understanding and their number sense.
Perfect. And we have a comment from Wasim. Thank you for watching us live, Wasim. That I want to address. So he says, we don't actually apply this in conducting classes of the students. How sad. And I think that's true, right? I mean, honestly, that's why you're here. That's why we have this book. That's why it's important, is because so often we don't see this in the classroom. And so, I think there's a couple of things, that are maybe worth thinking about with that, which is, one, especially this year in the pandemic, teachers are so busy and so overwhelmed and so exhausted that it can be hard to, add something on top of that, right? And especially with these new things, if we don't necessarily know if it's going to work, then sometimes we can get sort of afraid, when it might take extra prep time. And what if it doesn't work? What if it backfires? What if I accidentally do the exploratory thing with long division and everybody just, freaks out at me, So I don't know. I'm trying to think, do we have any tips for teachers who maybe are listening and saying, gosh, I wish I could, but I don't have time and I'm kind of afraid?
Oh my gosh, Allison, I've got 2 perfect tips for you. Okay. And I'm going to give a tip.
All right, cool.
I'm going to give a tip for parents also, but let's talk about teachers for just a moment. So if you are a teacher and you're thinking, okay, this is blowing my mind, this is crazy. Yes, it is crazy. For a number of years when I was in the classroom, when I had my own classroom, currently I support many schools and districts. I'm in classrooms every single week. I actually have some focus groups that I am still doing my own evidence-based studies with how this system and model works with them. So if you're afraid, what I tell my teachers, number one, 6 minutes a day. Set a timer for 6 minutes, give a stimulus. Now, would I love you to give a stimulus every single day? Sure, but maybe it's twice a month. Maybe it's once a week. Only do what you can handle to give it a try, but set a timer for 6 minutes. When that 6 minutes is up, that's it. Move on to your lesson of the day that might be totally unrelated. And let kids know that you're doing this. Say, hey, we're going to try something today because I really am curious about how you think and what your perspective is. Oftentimes I plan my lesson and I come in and I just tell you what I think. I tell you how I think. I tell you what my perspective is. I tell you what the textbook perspective is. And so I'm really curious and interested to see how your brain thinks about things. So this is going to be a little weird. It's going to be maybe a little icky. It's going to be a little uncomfortable. But for 6 minutes, I want you to tell me about this stimulus. I want you to tell me about this rectangular prism. What do you see and what do you notice? What can you tell me about this shape? And as a teacher, I want us to hold back in that 6 minutes. I don't want us to do any explicit instruction. I want us to just respond to students. Now, how do we respond to students? This is how I respond to students. When students are incorrect, many times, or maybe they have inaccurate thinking, because I'm not asking them to solve anything, but let's say they have a little bit of inaccurate thinking or misconception type of thinking. I will respond with, that's brilliant. I know this sounds really counterintuitive, but I will respond with, that's brilliant. The reason I do that is this might be a student that has never had success in our classroom before. And all of a sudden, all the students are like, whoa, I don't even know that what they're saying makes sense, but she's saying that's brilliant. Then I'm going to follow up with, your thinking is brilliant. Do you see, I'm celebrating their thinking and responses, not the accuracy. There is a time and place for celebrating accuracy, but it's not during the 6 minute stimulus. It's not during the sense making. It's not during the time that I'm trying to gain perspective into their thinking. The other thing that I like to do, and I'll respond with, that's brilliant, even with students that are correct. I mix it up because I don't ever want them to know. But many times during the trial period where I'm trying this 6 minute a day type of stimulus exercise, if a student has a really accurate, amazing response that's even more than what I even thought about the stimulus, I will say, oh, that is interesting. Now, what this does is, if this is a student that typically is very successful in mathematics, everyone now is like, are they not correct? They're always correct. I mean, you really mess with their minds for a moment, and this is deliberate and purposeful. Not that I want to make kids feel bad about what they're saying, but I want a level playing field. I want every student to have the same access. So lots of reasons that I do this, but I wanted to give that specific number one tip. 6 minutes a day, try a stimulus. That's it. Or 6 minutes once a week. That's it. Or set a timer. Go ahead.
In fact, we can even say 6 minutes once, right?
Once.
Get the first one done, right? Just get the first one done.
That's it.
Yes. Just start there.
The second tip for teachers, and this is really important because this is where the parent part comes in. I would only send home homework that was that procedural math ability type homework, because that's what parents know. Yes. So we don't want to make our lives more difficult as teachers, sending home some of this conceptual number sense type of thing, because it's not familiar. You know, kids might still be struggling with it. Parents aren't familiar with it. Then that's when we see all of the anger and the controversy in mathematics. We want to make sure that we're building those conceptual pieces in our classroom. Send home things for homework that everyone's going to be familiar with. So that is really the second biggest tip that I could give to teachers, is we really want to alleviate some of this struggle for parents. Now, parents, if you're listening, I have got a tip for you, because I'm a mom. I have a 16-year-old and a 12-year-old. I have 2 boys. I can't believe I have a 16-year-old, but let's not go down that path. But if you are a dad, a mom, an aunt, an uncle, a grandma, grandpa, if you are a caregiver of students and they bring something home and they're not really sure what to do, and I know the tears start, and you then want to send an email to the teacher, use these strategies as well. You know, if your kiddo is struggling, just use these questions and prompts. Well, tell me about this. What do you see? What do you notice? Just encourage kids to have a conversation, put them at ease. And then use the tip that I already gave when they start to tell you about whatever's well, I don't know, the teacher said this, and well, that's really brilliant. Tell me more about that. And so I think through these prompts and trying to gain student perspective and insight, it really calms the anxiety of the math situation as well. So hopefully those are some tips that people can take away and use immediately.
Yes. And I love this. I'm already picturing a student who's never gotten any positive feedback, hearing this is brilliant from his teacher, and then going home and hearing this is brilliant from mom or dad. And that can be such a game changer for students who are struggling. Well, gosh, I can't believe we're already out of time. I feel like we just got started. But thank you so much. This was all so fascinating and so helpful. Before we go, can you tell people where they can find your book and where they can find out more about you?
Absolutely. You can find out about me and get your free copy of 7 Fixes for Broken Number Sense at mindsonmath.com. And you can find my book, Making Mathineers, at Amazon.
And this is a fantastic book. I just got it the other day because it just came out. You just published it. And
yes.
Honestly, I have not been able to put it down. It has been such a fascinating read and such a fun read also. I love any book that can make, teaching students, or helping students with number sense more fun and engaging as a teacher is, a fantastic.
And Allison, thank you so much. You are so fun. You are so wonderful to talk to. And I love your podcast. I absolutely love it. You're bringing such relevance and relationships and stories to mathematics. So thank you so much for what you do.
Cool. Well, thank you so much. And thank you. I know some of you are joining us live on the video. So thank you so much for watching us live. And this will be an Allison Loves Math podcast episode soon in the next couple of weeks. So stay tuned for that also. Thank you so much for watching today. I'll see you next time.